Hi everyone, thank you for joining me again on the hashtag I am an engineer series brought to you by the Engineering Council of South Africa. This week we'll be focusing on understanding what is a complex engineering problem, how to achieve competence of Group A outcomes, as well as what are the key elements to focus on when applying for professional registration with ICSA. So getting into it, what is a complex engineering problem? A complex engineering problem can be defined as a high-level problem including many components that are linked. The solution is not always straightforward or obvious, and it might require some abstract thinking or originality to come up to the solution. And usually with a complex engineering problem, you would have more than one solution or option that you need to consider to determine the best one. If you find yourself having only one solution for the problem at hand, then chances are, as an engineer, you are not operating at the required level for an engineer, and your problem is not complex enough. In terms of how to achieve competence of Group A outcomes, it is important to understand that in the Group A outcomes, these are engineering problem solving outcomes, and there are three engineering problem solving outcomes that one has to satisfy. The first one is defining, investigating, and analyzing complex engineering problems. This is the process of gathering data to understand your problem. So in terms of gathering data, one can undertake literature review, desktop studies, as well as site visits. Site visits are very key to obtain data, as one is able to engage with the local community and find out information or problems that are not visible from a desktop study. For example, in my case, site visits are very important because by engaging with the local community, I'm able to understand when peak periods happen, because sometimes you find that you go to a site thinking that the peaks are normally around this site, that time, only to find that you've missed the peak. They actually happen a bit earlier, as well as what type of problems they encounter. Because sometimes when you go to site, you find that you arrive after the problems that you would normally see occur. In terms of the second outcomes of Group A, these are the design and developing of solutions for complex engineering problems. So now this is where the options, you now determine the various options that you have. In order to determine the various options, you can also engage other professionals to help you come up with viable solutions. I will explain a bit more in terms of designing and developing your solutions in an example after this. It is also key to note that in designing and developing a solution, the do-nothing option is also a viable solution. And the do-nothing option can help strengthen your case for the option that you eventually choose or deem to be suitable, based on various factors such as cost, quality, or time, whichever one that might be important for the problem at hand. The third outcome to achieve in the Group A category is comprehending and applying advanced knowledge. This is the use of manuals and calculations as well as softwares to solidify the final option that you deem suitable for the problem at hand. So by way of an example, I'll give a transportation example. Let's say you are an engineer on a road construction project, and during the construction process, you realize that you're developing sinkholes on your site. So the first step would be, you realize that there are sinkholes. You would then go to sites. You would also undertake some desktop studies and also try to obtain some topo information to understand what type of material you are dealing with. From all this, you then discover that you are constructing in a dolomitic area, for example, and you then, from your site visit, you discover or you notice that there's a points of standing water. So from institutional knowledge, you will remember from geotechnical engineering that dolomitic material is clay material which does not mix with water. So that then tells you that most probably the standing water is the root cause of the problem that you're encountering right now. And by doing your topo surveys, it also gives you an understanding that as much as you can get sinkholes in Ekurhuleni and you can get sinkholes in Carltonville, for example, how you go about it will not be the same because of the type of environmental or prevailing conditions that are there. Then you can now engage other professionals like a geotechnical engineer who can come in and undertake tests to then advise you the extent of the problem. As then you can also then look at viable solutions. So once the options are available to you, you can then look at, is cost important? Would you rather spend more to solve this problem but have spaced out maintenance periods, or would you rather spend less now because maybe there are or there are cost constraints, but then that means that you'll have high maintenance costs? So those are the type of things that you would then have to consider and be able to defend as to why your option is the best. And also in determining the solution, for example, in my case, we also at times use softwares to help us understand that in future, when this traffic grows, or even in the current scenario, how is the current, let's say, intersection operating? Is it operating at acceptable levels or not? And also in the example of the road infrastructure, you are then able also to look at other, by weighing your pros and cons, you are then able to also say that this would be the best solution for the problem at hand. So what are some of the key elements to focus on when applying for professional registration with the Engineering Council of South Africa? First and foremost, it is very key for you to understand what do the 11 outcomes entail, and then making sure that you have satisfactorily met or demonstrated competence in the 11 outcomes. Secondly, you need to download the latest forms, or make sure that you have downloaded the latest forms from the EXA website. Third, go through the forms in details. The forms are pretty much straightforward, and after each form, there's an information sheet which will explain and give details how you should fill the forms in. Fourth, after you have filled in the forms, written up your reports, and put your pack together, check it. Double check, triple check, even quadruple check it, just to make sure that everything is put in the right order and everything is filled according to the requirements of the EXA. It would also be advisable to engage an external person, or someone who is neutral, or even one of your mentors, to go through the pack for you as well, to check that you have filled in the forms correctly and you have demonstrated the competences for an engineer. The fifth point, make sure you engage your supervisors and your referees timelessly, as they will need to check the work and sign off on your work. Make sure that they are available to do that for you, and they give you constructive criticism that will ensure that you put your best foot forward. I hope these tips have been helpful, and they will be they've been helpful, and they'll help you in your journey towards professional registration. Thank you.